Hi everyone! So in this presentation we're going to be talking about water. Water is a very important part of our life on Earth. Just think about your daily routine. Hopefully you drink some water. We use water to wash our hands, brush our teeth. We use water to cook with, take a shower, and water can even fall from the sky and be flowing down a river. So water is pretty much all around us. The reason our planet is so special is because we have water on it. Without water on our planet, we would not have any life on Earth and everything would die. It's hard to believe that this odorless, tasteless, transparent liquid is so important to us. It covers about 70% of our planet. It makes up 60% of our bodies, and about 92% of our blood is water. That's a lot of water. So why is water so important to us? There are 8 factors that make water so special. We're going to be going over each of these in detail throughout this presentation, but for now I'm just going to list them. Water is a polar molecule. It has hydrogen bonding. It is the universal solvent. It has a neutral pH. It has surface tension, cohesion and adhesion, density, and high specific heat. Your first keyword is water. Let's start with polarity. What does this mean? Well, to start, let's go over what a water molecule is made of. Have you ever heard of H2O? The H stands for hydrogen, and the O stands for oxygen. The 2 behind the H means that there are 2 hydrogen atoms per water molecule. Over here in this picture, this is a water molecule. You can see that there are 2 white hydrogen atoms and 1 oxygen atom. Back to polarity. Oxygen is a electron-loving atom. Electrons are negative. The oxygen is going to pull the electrons away from the hydrogens. This makes the oxygen have a partial negative charge and leaves the hydrogens with a partial positive charge. So the electrons are going to be pulled towards this red oxygen molecule, which makes it a little negative. Right here, the symbol means partially negative. And the hydrogens are going to be partially positive because their negative is being pulled away. That's what these symbols mean. That is what makes water a polar molecule. Why is polarity so important? Because these charges are created, something called hydrogen bonding can form. Did you ever hear of the term opposites attract? When putting 2 magnets together, you will always have the sides that attract each other, but then you will have similar sides that repel each other. This is the same thing in a water molecule. The partial positive hydrogen and the partial negative oxygen will attract each other because positives and negatives attract. This forms something such as hydrogen bonding. This bond is weaker than the covalent bond that is in each water molecule between the hydrogen and oxygen. So hydrogen bonding occurs between 2 different water molecules when the covalent bond is within an individual molecule between the oxygen and the hydrogen. The hydrogen bond is between 2 whole separate ones. Covalent bonding means to share electrons, so that's what's happening here. Your second keyword is is, I-S. Water is also known as the universal solvent. This means that water can dissolve substances other than liquid. For example, when you put salt in water and you stir it up, the salt's going to go away pretty much. You'll see it dissolve. And that's why water is called the universal solvent. Water's polarity also gives it the ability to stick to other substances, forming such as a skin-type surface. It will stick together to form something called almost a skin-type feeling. And this is called surface tension. It can hold very light objects such as a penny or even a bug. So the polarity of those water molecules being able to stick together can form some kind of tension on the top of a lake or even a bathtub, and it can be able to hold these objects, even a paper clip as well. So your third keyword is or a. The term for water being able to stick to other water molecules, so water sticking to water, is called cohesion. Water can also stick to other polar substances. That's called adhesion. When it rains, water may stick in tiny drops to the windshield of a car, which is called adhesion, because it's sticking to something else. Cohesion and adhesion also allow water to move through roots of plants and small blood vessels. So I always think of it as water sticking away from itself, adhesion away. Your fourth keyword is polar. The pH scale measures the potential of hydrogen in something. If a substance is acidic, it will be in the range from 0 to 6 on the scale, 0 being the most acidic. So up here, 0, battery acid is the most acidic, and 6. So right up to there is all an acid. If a substance is basic, it will appear in the 8 to 14. Basic is 8 to 14, range of the scale. So ammonia is around a 12. Baking soda is around an 8. Water, which we're talking about, is considered neutral and appears on 7 on the pH scale. So it is the neutral on the pH scale. That's why it is so great. Move me down here. Density. Water is the only substance that can be a solid, liquid, or a gas. When it's in its solid state, such as ice, the water molecules are actually expanding. This is why ice is able to float in its liquid state of water. So it's showing you up here that the liquid water structure is more compact and closer together, and when it freezes into an ice structure, it actually expands. So that's why it's less dense and it's lighter and actually can float on water. Water takes a long time to boil and to cool down. You should know that if you're cooking anything. This is because it has a high specific heat capacity. That's what that's called. So the hydrogen bonding that we talked about, where the one water molecule is bonding with another water molecule, right, different water molecules, it causes water to have the ability to have a high specific heat capacity. As you see in the picture, the sun is pointing to the same amount of energy into the sand as the water, so it's hitting it the same area. the temperature of the sand has a higher temperature change than the water. So on our temperature thermometer here, it is higher than the water. So this is why when you go to the beach in August or September, the water is going to be a lot warmer than it was in May or June, because it had a lot more time to heat up. And a lot of people try and go to the beach at the end of summer because the water is going to be warmer than just going in May or June when the water hasn't had a lot of time to heat up. So your last keyword is molecule. And that's the end of our notes. So if we have any questions, make sure you ask your teacher and review your notes, because there's a lot of properties of water to know.